symmetries: T1U, A1G, T2G, and EG. Right. So this is then we said we applied SAGO of ligands, symmetry adapted group orbitals. In that there are 18 orbitals we have drawn. In that 6 are sigma. Its composition we wrote. Sigma was for ligand. This is for metal. So ligand I can say sigma orbitals. It was A1G plus EG plus T1U. And then this is the composition of sigma orbitals of the ligands. Then how it overlaps, we were just talking about. The symmetry has to overlap, then only it will be a bonding. Now composition of ligands pi orbitals, let's see. So I was telling that there are 18 ligand orbitals. In that 12 are sigma. No, 6 are sigma, and 12 remaining 12 are pi orbitals. Okay, so this pi changes into. So this composition is T1G plus T2G plus T1U plus T2U. So how we are getting it? We write the reducible representation for ligands, pi orbitals basically. Reducible, this is OH point group, right? So in the reducible form is reducible representation is 12, 0, minus 4, then it all becomes 0. 4 plus 3, 7, and 2 more zeros. So only these two will have some finite number, and once you reduce it, you will end up something like this. Then these are IRs. IRs you get T1G plus T2G plus T1U plus T2U. And if you start with the T1U symmetry, you just check the Caltech table of octahedral complex, which I wrote last time. At least partly I have written. So if you see T1 under T1U, it will have. So if you have under T1U, it will have what? T1U is fourth. So it will be Tx, Ty, Tz will be there. So this is Caltech table, okay? In Caltech table of octahedral complex, if you see IR T1U, if you see in the basis, so there will be Tx, Ty, Tz. That means it will have T1U will corresponds to T1U will corresponds to this symmetry will correspond pi x, pi y, and pi z. So pi x, if you project it out, how do you do? We do that after getting this, we project out the orbitals, right? So we project out the orbitals, pi orbitals, symmetry with respect to T1U. If we do that, then we will end up with 1/2 pi 2 plus pi 4 plus pi 5 and pi 6. So we get the linear combination of orbitals like this. Normalized one. These are normalized. So 1/2 pi 2 plus pi 4 plus pi 5 plus pi 6. I think you remember what is what I was talking. So there was various pi orbitals, right? Here you can see there are these are sigma, then there was pi 1, pi prime, like that I was writing. So this is pi, something like this I was writing. And then there are orbitals from here, and then so these are various pi's we are talking. So pi 2 is here, pi 3 is here, pi 4, pi 5, and pi 6. So similarly you will have for y. In y-axis, so we define this as x-axis, this is y-axis, and this is z-axis. So pi y will have this side. So so this is pi 1. It doesn't matter. It's all symmetric. Pi 3 plus pi 5 and pi 6. So I'm not deriving it. So it's not necessary derive it. At least have an idea how it will be. Phi z is very simple. It will be these two will not be there. So it's all pi 1 plus pi 2 plus pi 3 plus pi 4. That's it. So all these orbitals will be involved for pi z. So this is T1U symmetry. Similarly, one can write for T2G. This is done. Similarly, we can get it for T2G, T1G, and T2U. You will get some combinations. Okay, so that is the way it forms. Now I'll just write it in a table form. Which orbitals of metal correlate with the or overlap with the orbitals of ligand? Then so I'm not doing anything new. I just took the pi orbitals of ligands. Then we got this representation by reduction method, and then we are using the projection operator method to get the or symmetries of these orbitals. We got the linear combinations. Now I'm going to. Now we have all covered. I think so. Metal, ligand, all these things. Now we are. I'm going to write in the table form. Okay. Let me write in the table form. Where is it? It's too tough. Say there is IR and then metal and then ligands. So A1G, if you take in octagonal complex, metal has s orbital, and then here the ligand sigma s orbital will overlap. And then if you take T1U, IR, and then there'll be in metal ion, there'll be what? This is PX, PY, PZ. So these metals T1U, there'll be, and if you see in the ligands, it will be two types. One is sigma X, sigma Y, sigma Z, or pi X, pi Y, pi Z. So this is overlap, something like this, which will have T1U symmetry. If you go to EG, then it will be D x square minus y square and dz square of metal. And then here it could be sigma x square minus y square, sigma z square. So it was overlapping like this, EG. So if you remember yesterday, we were talking only this one in last class. We were talking about this. There were sigma orbitals for for ligands that has EG character. And now T2G. If you take T2G, so it will be metal d orbital. So it's basically dxy, dyz, and dzx will be involved. And here ligands. Similarly, pi xy, pi yz, pi zx orbitals will be involved. So it's basically yes, yeah. So if you see in the character table, you can find out there will be characters of xy, yz, zx. So in metal, it's all d orbitals, and in ligands, it will be pi type, not sigma type, but it's pi type. That's what we get. And there are orbitals. If you see in metal or in ligands, so if you see this is metal, and if you see in the ligands pi orbitals, I wrote T1G plus T2G plus T1U plus T2U. If you remember, I just wrote these things. What after all these exercise, so this T2G is taken care, T1U is also taken care. Yeah, I mean there's an overlap. Okay, so among the metal and ligand, But these two, T1G and T2U, they remain, they don't overlap at all. They don't combine with the metal orbitals because the orbital doesn't have these two combinations. T1G is not there, T2 is not there. So ligands, although those orbitals are present of this symmetry, they don't overlap with the metal. So they remain as non-bonded or we call it as non-bonded orbitals, right? So it will remain without combining with the metal orbitals. So with all this exercise, we just see which metal orbitals of which symmetry overlap with the ligand orbitals of corresponding symmetry. So if it is T1U of metal means it's P orbitals of metal, and then either sigma or pi of corresponding ligand orbitals will overlap. There won't be a crossover. T1U, Px will not overlap with the sigma x square minus y square and sigma z square. So it will not happen. There will be a symmetry has to match. Okay, so ligands has orbitals, different orbitals, metals has orbitals. Their symmetry has to match for the overlap. Then only lead to the bonding. And this information is provided from the Cantor table. Okay. So this is this is the exercise explained for the octahedral complex. Similarly, one can study for the tetrahedral molecules or complexes or square planar complexes. You will find many examples in various books. Yeah, so I stop it here with this this one, and then so group theory basically provides a qualitative picture of overlap with the symmetries. Whereas if you want to know the quantitative thing, and then one has to go for a quantum chemical calculations. You have to use a quantum chemistry part of it. Like if you want to know which energy, how much is the energy level, those things you want to know, then you have to go for the quantum chemistry principles. But group theory will tell qualitative, give you a qualitative picture. It will tell the symmetry only, overlap, which symmetry will overlap with which symmetry of orbitals. But it won't give the energy ordering, just tell the qualitative picture. Okay. So there is a MO picture. I can just draw that. Okay, so I think I just want to cover this part. Let me finish this one also. I think so. There is a MO orbital diagram for octahedral complex, just to show, say, metal d orbital. So metal ion or d orbital, you can say. Then you have ligands, ligand group orbitals you have, and then it gives to molecular orbital. These are atomic orbitals. It gives a molecular orbital. So if you take T2G, and just above is EG. So ligand it has sigma and various pi orbitals. The sigma is here, then this is of EG type, and there are pi orbitals also. These are all pi, and this has one is T2G, T2U, and T1G. These are all pi of ligands. So this is EG. So you know, right? So T2G and T2G will interact, bring down the energy. So bonding orbital, and then there'll be a corresponding anti-bonding orbitals for T2G. And then EG also, there will be a combination of energies. The other way also. So I would say I just leave it here. Comes all the way. So this is for EG, and what I'm saying is these two orbitals will remain vacant. Although they just available, they remain vacant. This is T2U, and this is T1G. So although it's available for pi, it will just remain vacant. So these are all asterisks. It's corresponding asterisks. So anti-bonding orbitals. So here are bonding orbitals. I think you are familiar with this diagram. I hope so, right? Yeah, I think you are familiar with this. So what we are saying is proper symmetry, there will be overlap. And then if there is no corresponding orbital of that symmetry not available in another metal or ligand, then they don't overlap. They just remain as such. So this information one can get it. Okay. So before I go to the next topic, the quiz paper, can I solve it now? So average mark so far, I mean, I have evaluated it. I'm going to send it by Google Classroom. I'll just return it. The answers I can provide. I think most of you have done it, but some people struggled. I don't know why. So out of 20, the average is 11.6. It's just 55%. I was expecting 14 or 15, maybe the average, but average is very low, below the expected value. Anyway, I'm going to return it. You can take a look, but now I'll just give the answers. First one was quiz. This was quiz 1. You can compare it. I think you have the answers with you, right? I mean, the solved papers are with you, but anyway, I'm going to give the evaluated one. So other thing is I reduced 1 mark for 3-minute delay, 2 marks for 6-minute delay, and 3 marks for 9-minute delay. Okay, so if there was 1 minute late or 2-minute late, it's okay. I just left it. But there are people who made it a little longer. So that's why we just reduced it, because some people could not finish the paper during the time, and even then they have submitted it. They just submitted the answers even before completing the answer sheet. Whereas some of you have taken a little longer also to finish the paper. So to be fair, we have to reduce it since we have informed you long back. So answers. Okay, I think this is fine. I think, right? Okay, so those who are late by 1 minute or 2 minutes, that's okay. We are just allowed. But more than 3 minutes, I mean, 3 minutes is 1 mark dedicated, or correspondingly like that. So this is first one is we have to get the reducible representation. So reducible representation for BF3, I think. So this is D3H. So one is what? First one is bond axis, bond vectors. So if you see the bond vectors, it is 301, 301. So D3H. If you write it, they will give the D3H point group as such that. So it is E2C3, 3C2, sigma H, 2S3, and then 3 sigma P. So gamma of say bond vectors, you can say bonds. It was 301, 301. This everybody have got it. Most of us. It's 301, 301. Other one is Cartesian coordinate. Cartesian coordinate. So it should be 4 atoms are there. So there will be 4 into 3, 12. So anyway, it's 0. This is -2, 4, -2, and 2. Some people had problem in this. I don't know why. So this one is BF3, right? F. So there will be 3 vectors each atom. So whichever you can say, it's X1, Y1, Z1. So like that you label it. So 12 is nothing. So C3, when you perform C3, it is all getting shifted. So that gets 0. Yeah, that's why it's 0. Whereas C2, if you perform, C2 is this way. If you rotate it, these two atoms get changed position, so that is get 0. And
Excuse me, sir.
yeah,
Sir, you have answered it using 3 coordinate system. Can't you answer it using XYZ simply?
you can use what? X1, X2.
I have used it only
Let me get a
single
earpiece. Huh?
coordinate
I have
system.
problem in the, I think there's a mic problem in my laptop. I'll get an earpiece. Just give me a moment. Yeah, go ahead. Somebody was saying something. Please.
Sir, sir, I want to ask. You are using here 3N coordinate system, right?
Yes.
Can't we use single XYZ system? I have
How
answered
do
it
you use
using
it?
XYZ system, not by 3N.
How do you? Okay. The XYZ system. Where? Can you
Taking the whole
explain
molecule as
further?
in
I mean,
XYZ system.
XYZ as a whole molecule.
Yeah, sir.
Then how do you get this? See, whenever we say Cartesian coordinate, no, we take it for each atom. For each atom, we even for the central atom also we give. I mean, we consider its Cartesian coordinates. So, not for the. I have to check whether it is right for whole molecule or just taking X Y Z. That we can use it.
Okay, sir.
I'm not sure. I have to check it. I'm not sure. But to my knowledge,
I haven't seen. So
I understand you have
they
taken whole molecule as
especially
one
3N.
here, and then
Yeah,
right,
yes,
your
sir.
whole molecule are taken XYZ, and then you have taken reducible basis. That means it's just 3 something like that. You'll get 3 0.
Yes,
I have to check it. I mean, to my
yes, sir.
knowledge, Cartesian coordinate means for each atom in a molecule, how the vectors change. Cartesian this is vectors, how the positions change. That we generally follow. Okay.
Okay, sir.
Maybe I'll check it
Okay,
out
sir.
with others, and then it's possible or not. I mean, to my knowledge, it's all per atom only, each atom only. So I think, yeah. So I think for those who had trouble, I think people might have worked out. But this is the answer. So if you rotate C2 along this, and then these two will interchange, and then two vectors will go to the negative sign. Basically, Z and X will go to the other side, and Y will remain as such. So for two atoms, so it is -2. Similarly, sigma H, 4 vectors remain as, I mean, 6 vectors. These two all will in the plane, whereas all the Z's, 1, 2, 3, 4, all Z's will go to the other side of the molecule. That's why you are subtracting it. So this gets like this. Since C3 is 0, S3 also has to be 0. No, C3 is 0. Why it has to be, no, C3 is, S3 is C3 followed by sigma H, no? So C3, I mean, this one is not changing, B. And then S3 is sigma H, if you perform, it remains -2. So how do we get that? Let us try. Okay. S3. I think most of you got it, but S3 is C3 and then sigma H. So if you rotate the molecule C3, so these things will get cancelled. And then B3, what happens? B. So this is say X4, Y4, Z4. rotate it, and then Z will remain Z, whereas -2. So you're rotating this, so this will come here. How do you get this S3? No, I think we have to consider all three. All three items to consider. So how do we get? Is it? How do we get S3? C3 followed by sigma H. Right correctly or not? Let me check more time.
S3 will be -2.
Sir, it is correct.
Yes,
Correct, right?
yes, sir.
Right.
But
How
for
are you?
sigma V, I think there should be 3 because there should be two unshifted atoms.
Sigma B.
Yes, sir.
Just give me a moment.
Sorry, it will be 2 only.
Yes, sir.
Sure.
Hello,
fine.
sir.
Yeah, go ahead. So how do you sigma
Sir,
B?
as far as I,
So this way. So what
Sir?
happens? Yes, these two atoms interchange. We are just placing it on ZZ. So what happens? So these two will go negative. That is fine. I think 4 positive, 2 negative. Okay, so this is perfect. This one is perfect.
Sir?
Yeah.
Sir,
Yeah, go ahead.
sir, for the Cn and Sn, sir,
Ah.
in Cartesian coordinates, as far as I know, there is a formula which is used. For the Cn, it is 2 cos theta plus 1, and for the Sn, it is 2 cos theta minus
Theta
1.
-1. Yes.
Okay. Yeah, because of C3, no? I mean, it is 120 degrees.
And sir, will we get benefit of doubt in case of if a person has done some confusion in S3?
Yeah, sure. Yes. 1 mark. Okay.
So can you explain the sigma V again? Because I got the 3 as answer there.
So I write this as x2, z2, y2. Okay, and then here x3, y3, z3, and again x4, y4, z4. Okay, so if you place a mirror across this plane, across this side, these two will interchange, so forget about it. Unshifted. You have to consider these two atoms are shifted, so you don't have to consider. So these two are unshifted. So in that, what happens is Z and Z and Y. It's not shifted. Okay, so there'll be a 4 unshifted. Whereas here, these will become x4 will become minus x4. Okay, this will become minus x4,
Okay.
and this will become minus x3. So -2. So this will be 2. So that is fine. So maybe C3, yeah, maybe basically we have to use the angle. I think 120 degrees. So, and then I think that maybe some group. Anyway, I'll give marks for this. So C3, even if you have there's some problem. Okay. Yeah. I thought it was simple now. For Cartesian coordinates, yes, we may have to use this angle. So it was not straightforward. So next problem will go. So group multiplication table, it is C2H multiplication table for this molecule, so trans Cl. So this molecule is C2H, and then I think most of you have done it. Maybe one student have put. I'm surprised at this stage why you are putting. They have put two i's together. It was like this. Yes, it was like this. Yes, I, and I mean for each it will be different, right? For the four IRs, it cannot repeat. No, I mean the same row it cannot repeat. So one of you have written II. I was surprised to see that. So only one person had made that mistake. Otherwise, everybody got this. So I just keep this this table. Next is normal corners of Cl3 molecule. Again, this is third problem. So C3V, and then determine number and symmetry. So CHCl3, right? So 3, 4, 5. 3 into 5 minus nonlinear molecule. 9 moles. So if you find out, the answer is all 9 are IR and Raman active. So it is Y is 3 times of A, 1 plus 3 times of E. Okay, so this is the vibrational mode symmetry 3. So see, I mean, best way is you have to compute how many vibrational possible, and then if you count. So this is 3, no? So this is 3 e of 1. It's a 1 dimension, and then plus of 3 times of this is 2 dimension. E is a 2 dimension. Okay, so if you count it, it should be 9. You can see 3 into 2, 6 plus 3, 9. So that should be 9 modes should be there when you find out the vibrational modes. I have seen half of them have reported 8 modes. I don't know why. I mean, it is 8 modes or 6 modes. Some people have written. Some people have written 5 times of this, and then 4 times of this. If you put 5 times of this, E plus 4 times of A, of course you get 9, but this 5 into 2, 10, 10 plus 4, 14 modes will come. So remember, this is doubly degenerate. Okay, so and T means triply degenerate. So you have to count that one also. So you cannot put like that. So this is many of you have made problem. I mean, had problem in this. And C3 point group we have given already. So I think you can 9 modes. Both are. See, this is A1 and E, right? So if you see the character table, A1 has E, Z, and then E has X, Y, and all these things. Both Raman and IR active. All 9 modes are Raman and 9 IR and 9 Raman modes you will get. Okay, so you get 9 modes. Of course, how many peaks means? Yeah, it's a doubly degenerate. The number of peaks will be less, but all are active. Okay, I suggest you practice more with few more examples. Then you will appreciate it better. You take some more examples, ammonia or carbon dioxide, any molecule you take, simple molecules, and then work it out. Then you can find out. So yeah, only half of the class had correctly done those. Otherwise, there's a problem. You have to use the Russian formula appropriately. Yeah. So fourth one, yes. Yeah. So many. Yeah. So almost all have got it. Fourth one is So basically, yeah, if you have A1 and then so dipole moment components, and then say B2, say water molecule in this case. So if it vibrates on mu x, so mu x has its own this one, and say mu x. I mean, it should result in A1 symmetry. Then it becomes dipole moment change is not equal to 0. So the integral will be non-zero only when the direct product of ground state, its dipole moment component, and external state orbital results in symmetric representation, totally symmetric representation. If you take water as example, A1, B2. If you take some other molecule, it could be AG and B, B or AG and another AG. Then it should be AG. Okay, so it should be highly totally symmetric representation product. Then only it will be give signal. So fifth one is number of classes. So water, everybody knows so water has 4 IRs, but so the number of IRs is equal to the number of classes. So only thing is you have to prove it. I think the question is you have to illustrate that. Yeah, how many classes are present in C2B in point group? Because I have already given the cat table in the backside. You have to prove it how it is. So you have to perform the similar transformation for every element. So for E, C2, sigma V, and sigma V prime, if you perform a similar transformation, then you will get same T. You get C2, right? Whatever you take, you get the same T. Unlike C3V, the C2V always results in sigma V and sigma V prime. Okay, so again, it will be there will be 4 classes. Those who have written 3 classes, just notice these 2 are separate. Sigma V and sigma V prime are different. They are class by itself. Okay, so that you could have, I mean, done it by just multiplying with other elements and then seeing it. So there will be answer of, I mean, there will be 4 classes.
Sir?
Some people have done 3 classes, so that's why I'm saying you have to prove it, illustrate it. Those who are just given the answer, they got only partial mark. So at least you have to derive it. So sixth one is BCL3 molecule. This again DCH. I think we have done this in the classroom. So basically it is the same one I have just given. Those who have done it, so PZ orbital corresponds to pi, and then PX, PY corresponds to sigma bonds of BCL3. This answer I was expecting, but partially also it's fine. I think most of you have got it. So if it is out of plane, the reducible representation is 3, 0, minus 1, minus 3, 3, 0, 1, and for that people got A2 double prime plus gamma of E double prime. So from there you get the answer by looking at the scatter tables. And for the in plane orbitals, it is again 3, 0, minus 1, 3, 0, 1, 3, 0, minus 1. This matters. So for this A2 prime and then gamma E prime, you will end up. So if you have shown this, then you get this by reduction formula, right? So you just get this and then correlate it. Then we can answer. This is a solved problem. I think in the classroom we did this. So nothing much to say about this molecule, this example. Seventh is this, yeah, everybody have done it. X, Y, Z, R, Z is A2. I don't know how you got it, but most of you have written it. So yeah, again, this will be A1, and this one is B. This is also B. You can work it out. This is X1 and 2. So if you notice the character table, I did give the characters of these. In the question paper, I left it blank. The bases I left it blank, so that you can find it out. So So this you have to just rotate the molecule and see whether it changes. X-axis changes or not. The vectors changes when you apply in D1. X doesn't change, so that's why it is like this. So I think most of you got it. I hope you got the RZ also, I think, right? Eighth is okay. So this is first one is simple. No, not simple. AU plus PG plus PU. So this is a complicated one. I'll come to the second one easier. Okay, so this is A1 plus B2 plus B2. So this is we can say this is A1 plus B to B A 2 into 2 1, and then it becomes A1. So this is the second answer. Say 2 into 2 is 1 here. Okay, you don't ask me how, but it is the notation is multiplication of B to B will give A, and 2 into 2 will give 1. So basically, you know the characters of B1 and B2, right? So from that you can make it out. So B1 is 1 minus 1, 1 minus 1. B2 is 1 minus 1 minus 1, 1. So you take the product, I think you should get B2 should give A1. 1 minus minus plus 1 coming like this. No, B2 into B2, right? So I have to multiply with just B2 into B2. So this is B2, B2, 1 minus 1 minus 1, 1. So it will result in A1. So this into this into plus 1, 1. So like this we get it. So you have to multiply the characters and then get
Hello,
it.
sir.
So A1 and A1 will always give A1. Similarly, you have to try
Sir?
AU. See, if you don't know the notation combination, then we have to use the characters of that character table and then do it. So I told you U into G is always U, and G into G is G, G into okay U into U is U into U is G. So if you do this, you can say AU plus T into T will give T, G into U will give U. So this will be A into T will be T, U into U will give G. So this also TG. 90% of them are wrong in this. Even more, I think. Maybe 1 or 2 students did it correctly.
Sir?
But most of them have gone wrong. Whether it is T into A is A, or some people have written T into T is T square. So all sorts of combination. The best thing is it's an open book exam. You have the matrix of, you have the characters of character table of any of the point group which has G or T. And see, A into T cannot be A because this is 1 dimension, this is 3 dimension. So when you multiply it, no, it cannot be A, it should be 3 only. That means it should be result in T only. Because you are multiplying the matrix. A you will have 1 minus 1, something like that you have. T will start with T, 3 minus 1, something like that it will go. So when you multiply 3 into 1, it cannot be 1. So it should be 3 1. So
Hello, sir.
product should be T. And then U into U, I think this we know. So ungraded and ungraded will give G. So yeah, most of you have cracked this, but this one, except 1 or 2, all had problem. Okay, you agree with this? If you are not clear, you just take the character table of one of the point group which has AU, TG, TU, and you just multiply the characters and see whether it results in TG or not. Yeah, you just multiply these two, TG and TU, you should get TU characters, and then you multiply TU and AU characters, you should get TG.
Sir?
सर ने शायद
Sir?
numbers लगा रखे हैं.
This is 8, 9 is 9 is if you do it r squared, then results in 2 theta. That's the answer. So, only those who are attempted the two matrix form, you have just tried the multiplication. Maybe you have not gone all the way to writing this cos square theta minus sin square theta. That corresponds to cos 2 theta. So that even if you are not written, I have given marks. So you just most of you have got this. So it's 2 theta. You get it. R means theta rotation, and then R2 means 2 theta rotation. And 10th one, everybody have done it. Okay, so 10th one is 10th is boric acid. It's 3-3. So it's C3H, and the other one is cyclohexane, C6H12, both. This everybody has done it, so C2E. Although I don't know how you got it, suddenly people have just written the answer, so I'm bound to give the answer marks. So. Okay, so this is what it is. So shall I send any question in this? What are your solved now?
Sir,
Sir, hello sir. Sir, earphones लगा लो.
sir earphones.
How many people are there? 19. Somebody can say yes. Sir, yes, go ahead. Sir, use earphone. No problem, you can speak. I don't know, my computer is now 6-7 years old. You know. Now after using Google Meet, I came to know that speaker has problem. Okay, go ahead.
Hello sir, can you listen me?
Yes, yes, very much.
Yes. Sir, I was just asking if we have any doubt regarding the marking, can we contact you regarding that?
Yes, yes, most welcome. Why don't you contact? You contact now. We'll again rework on your answers and then we'll update the marks. Okay. So if you have problem, if you feel no more marks should be given or appropriate marks should be given, just let me know. Either way, by email or by Google Meet. I mean, the Google Classroom. I'm going to send it. So you can send. You can contact and then I'll update it. Okay.
Okay, sir. And one more thing,
Yes.
sir, that the seventh, that which one is seventh or eighth question?
Yeah. Which one?
That direct product one.
Yes.
Direct product. Sir, in the second part, do we need to show the multiplications of their characters, or we simply need to show that
No.
A into B?
Just you have to
only
give the
sufficient?
answer. That's it. You have to just give the answer.
Sir,
Okay, sir. Thank you, sir.
I have also one problem, like TU and TG, when we do direct product,
Yeah.
and how answer will be TU? Because this 3 into 3 will be the identity will be 9. So
No, that
it
is
will
a normal matrix multiplication. If you multiply, then it becomes 9. But normal in direct product, no. 3 into 3 is 3 only. 3 direct product of 3 is 3 only. It cannot be 9. No.
it will be collection of some irreducible representation. And it also
collection
depends
of-
upon the point group also, which we are multiplying.
Yes, yeah.
Yes.
We have, but it won't be 9. Let me see. I have some examples. Okay,
Yes.
with the character table.
And
Yeah, go ahead. Yes, and you're saying something.
yes, when we are doing direct product of like two-dimensional or three-dimensional this irreducible representations, then it usually depends upon the point group which we are taking, because there are different dimensions.
But this is a general notation. If you take a product of t into t, it will always result in t only.
and E into E. If you multiply EG into EG, it will result in EG only. Okay. I'm not getting 8 minute. KM3D. Let me work it out. T1G, T2G. So this is T2G. T2G is there? Yes. So 3 into 3.
So like for example, if we follow the TH
Yeah.
point group,
TH.
there will, yes, there is TG and TU. When we do the direct product, we will get 9001, -1, 0, 0, and -1. Then we have to use the reduction formula to find the irreducible representation.
Okay.
That is the,
So yeah, if you do that, what you will get finally? Finally, TG and TG, right? Or TG and TU? You said TG and TU, right? Reducible form, and then yeah, finally what you will get, even if you reduce it, we end up with again TU.
that we have to check.
Ah,
I
that you
have
have
to
to
solve
check.
it.
I suggest you try it. Yes, yeah. Finally, yeah. So the notation wise, T into T, direct product is again T, and Gered and G is Gered and U is U. Maybe reducible form you have to write, and then again solve it to get the final one. But otherwise, directly it is should be like this. Check it up. If it is a different answer, if you're getting, let me know. But
Would be different, sir, because when we say it would be TG plus TU, then the representation would be not the same as the reducible representation. I will check and mail you.
check it. Yes, yeah. You
Yes.
can let me know. Okay.
Hello, sir.
Yeah. Go ahead.
Yes. Sir, in fifth question, I have not done the similarity transformation, but I have written the reason for the classes, for the 4 classes.
What reason?
Like how the different symmetry operation form different class.
That's what I don't know. I mean, one way is similar transformation. One way to prove it that it has different class. It's class by itself.
Yes, yes.
So I was expecting that will be you have to prove it, illustrate it how why it is only 4.
Okay.
So if you have done just 4 classes, I give 1 mark, and then if you prove it at least for few cases, then another 1 mark.
Sir, another thing is I have written a wrong question number on one
That's
question.
okay. That's okay. That's no problem. So other one no other. I just want to suggest to all of you. So these are all online answering, right? You answer in your white sheet and then upload it. So my sincere suggestion is you write each question in separate paper. You maybe just one side you fill only one answer, and then don't start the second question in the same sheet. Once you finish your answer first question, don't start please don't start the answer in the same sheet, because we are evaluating everything in either in mobile or in a laptop, it becomes very, I mean, it's too congested to see in a normal screen. Some people write numbers differently, and then difficult to follow. Either it's 6 or 9 or 8, the question number, we really could not follow it. If it is written paper, no, then I mean the hard copy paper, then it is we can see it. But in a computer or in a mobile, if you are, when we are evaluating it, it becomes very difficult. It's too jumbled. Sometimes we don't consider the question number at all. We just see the answer. Okay, this should be the question of answer of this question. So we assume like that and then give mark. Fortunately, in this case, I gave equal marks for all the questions. So it doesn't matter whether you interchange the questions. So one way is yeah, you give one answer in per page. Even if some space is left, just leave that blank and then go to the next slide and then give the fresh question, answer the fresh question. So in that way, it will be much easier for evaluation also, and there won't be we don't miss it, because sometimes in one sheet there are 3 or 4 answers, and people have written 2-3 lines in between, number is not visible, and then we skip it also. Sometimes we may skip it. So to avoid that problem, I suggest separately you write it. Maybe a few pages it's going to take extra, but at least you'll get. I mean, there is a guarantee of every question has been evaluated. Okay.
Sir,
that's
what is
my
the
question.
highest score?
Highest is 18.5 out of 20. And lowest is 4, I think, 4 of 5. And then average is 11.6. So once I send you back the solved one, then you can see there could be, of course, yes. Once you, if you think some mark is missing or it's not sufficient given, that we can always work it out. Okay, I'll increase it.
Sir, in ninth question,
Yeah, go ahead. Ninth.
two matrices are multiplied and then trace of the matrix is calculated by this R square. We have to calculate then the trace.
No, not trace. No, theta. What theta you get it? If you multiply, see, you have to just multiply cos theta minus sin theta 0. That one matrix there. Another matrix you take, and then R into R you have to perform. If you do that, then
sir, in the I've just find out the R square matrix, but don't write it is 2 theta. It is fine.
I would have given a partial mark. Okay, if not 2 marks, I would have given at least 1.5 or minimum 1.
Sir, I have also only multiplied only.
Yeah, so I should get 2 theta answer. So if it is R is theta and then other is 2 theta.
Okay.
So the rotation through angle theta, no? So R is rotation through angle theta. What is R square means? 2 theta is the answer.
Sir,
If you have written just 2 theta, that's sufficient.
Sir, I didn't multiply the two matrix. I just showed in these Cartesian coordinates that from alpha to first we move to theta, that one rotation and then second rotation the second theta. So total after like that I came to 2 theta thing. Will it be valid?
I'll check again. I mean, what is your name?
So Robin.
Robin, I'll just check again. You reply back, okay? Once I send it to you, you reply back. I'll take a look.
Okay.
But as per my knowledge, 2 theta should be the answer should be there. Then only I give.
Yes, sir. My answer was 2 theta, but I came to it through a different way.
Okay, might be I might have given full mark if I have written 2 theta. If not, let me know. Okay.
Okay, sir.
So I stopped this recording.
I have